So, hello guys, we have Moez again with us, and from the viewers' demand, from the past video, it was an amazing podcast. So over there, people wanted you more, to give some kind of sessions, and they also saying that okay, make some end-to-end implementation. So probably in this video, we'll try to do that, and let's see, like you can actually explain what you're actually trying to do. And now I'll be giving you, you can share your screen and you can start the explanation. And probably this video will be for somewhere around 30 to 40 minutes. So guys, please enjoy. And yes, Moise, you can continue.
Hey Krish, thank you again for having me here. I'm glad that last video was helpful to many people. So today, in the interest of time, what I have done is I have prepared a little presentation so that we can finish on time. And now I'm sharing my screen. So can you see my screen?
Yes, Moise, again.
Okay. Okay. So let's get going. So today we are going to talk about integration of Pycaret with Power BI. And just to get started, there are some key links. This is our website, our GitHub, and this is my LinkedIn profile. You can reach out to me in case you have questions. If you have issues while implementing this, and this is a hands-on tutorial, if you have issues, the best place to log your issue and get an answer quickly is GitHub, because obviously reach out to me through a private message, I would take very long to respond, as opposed to if you post the issue on GitHub, somebody else would definitely help you. And there are people who had issues with installation, with issues with environment, and other issues, and there are responses available. So there is a possibility that the issue that you are facing is already being resolved by somebody. So if you are not already used to using GitHub, please get used to the idea of being able to navigate through GitHub. And we will try to cover three demos today: one supervised regression problem, one anomaly detection unsupervised, and one clustering unsupervised. And there are repositories on GitHub, and the links are here. So, and even this presentation is uploaded on this repository on my GitHub Pycaret deployment Power BI. So you'll be able to get that. So with unsupervised clustering and anomaly, what we'll do is we'll not only just integrate and build the model, but we'll also visualize it in Power BI. So there's already a PBIX file on the GitHub repository. So what you can do is just download, plug and play. Okay, moving forward. Okay, so what do you need today to follow along this tutorial? You need three things. First thing is Anaconda distribution. So if you don't have not necessarily Anaconda distribution, but any distribution that provides you with Python 3.6 or greater. So most likely you would have, and it's very common to use Anaconda distribution. If you don't have anything, I would suggest, instead of figuring out yourself, just go ahead and download Anaconda distribution with Python 3.6 or greater from this link. And it's a very simple installation, just next. One thing for people who are doing it for the first time, when you are installing Anaconda and Python, one option in the installation, and probably the last option, is add Anaconda and Python to the path variable. You have to check that box off. Check that box if you are doing it for the first time. The second thing you need is a Power BI desktop version. So you can use any. I'm using May 2020 version, so it's recommended that you use updated version or recent version. Although Microsoft Power BI, I have never seen a issue with back compatibility, but it's recommended that you use the latest version. And then Pycaret, and to install Pycaret, you obviously need the first one, which is Python, that you would download or install using Anaconda. Uh, Okay, so because this part is common to all the use case and demo that we'll see today, the first thing that you have to do is create a Kona environment, and I would show you how you can do that. So these are three lines that you need to run, but how you need to run, I'll show you. So if you have Anaconda distribution, you go to your Windows Run menu, look for Anaconda prompt, and you'll see something like this, a black screen, right? And to create an environment, so why we are creating an environment? So your Python installation comes with a base base environment, right? And then if you are working on projects, there are times where you would use different versions of the same software and you don't want them to conflict. So for example, you could have TensorFlow 1.x models running in production, but now your new development is on TensorFlow 2.x, right? And you don't want that to happen in one environment because of conflicts or version dependencies. That's why we create environment. It's like a container to isolate everything within one box. So, and also for Power BI, Tableau, and tools which support Python integration, they need some kind of environment to point to. When you run and execute these scripts in those softwares like Power BI, you need Power BI to read an environment because your base environment wouldn't have the packages that you need. So that's why we need to create environment. To create environment, simple code, conda create, and let me see if I can zoom. Yeah, conda create name, and then I have chosen Power BI as the name of my environment, right? You are free to choose any name, and then you just have to mention version of Python. I'm not going to run this command because I've already done it. And when you execute this command, it would prompt you for a yes or no confirmation after a few seconds. So you press yes on that, and it would take 8, 10, 12, 15 minutes to complete. Once this step is complete, you can activate your environment. So in this case, see this base on left hand side. This shows that I'm in my base environment. But because I've already done the installation, I'm gonna activate my environment by writing conda activate Power BI. And as soon as I write that, as soon as I execute that, oops, I think I am having some difficulty. Let me come back. Anaconda prompt, conda activate Power BI, and look at this. I am now in my Power BI environment, and once the environment is activated, you can install Pycaret using pip install Pycaret. Again, I'm not going to do that because I've already installed it. So if I do pip freeze, you would see all the packages that I have in this environment, and I haven't installed any of this. So what happened is when you install Pycaret, which is this, just by running pip install Pycaret, it would install all the dependencies. So it's kind of containerizing everything so that you don't have to manage your requirements.txt. So that's why you would see there is get boost here, there is boto3, there is scikit-learn, and everything else. There is xgboost, everything else that you would need. So you only need to install Pycaret and it would manage all the dependencies. So this was a raw environment. It had nothing in it when I created this environment. Just pip install Pycaret would install all these things. Okay. Now, if you have issues, if you are using Mac and you have issues in installation, you should go to this website, pycaret.org/install. And for Mac users, we have some specific set of guidelines. They'll have to install Microsoft's Light GBM framework separately for some reasons, but there is a guideline there. And if you find and if you face any error, this is open source, right? So errors are not something we can avoid. So if you face any error, I encourage you to look on our GitHub page, and there are many people who have faced issues with Power BI. Most of them are version conflicts and stuff like that, but people have responded. So let me show you an example. Um, um, I would go to my Pycaret GitHub repository and then go to issues and search for open issue. Just write Power BI for today, and you would see this Power BI issue with Pycaret. And most likely in Power BI, you would have this error, ado.net. The traceback of Power Query is not so strong, so it's unlikely that you'll be able to understand this message. But every error I have seen is would start with in a similar way. Now, this is a issue many people faced, and then somebody has also solved this issue. So if you would go to the um, last message of this thread, you would see somebody has basically proposed a two-step solution to solve this problem. So if you face a problem, the best place is to open up GitHub, look for Power BI issues, and I'm sure you'll find an answer. If it's a new issue, I'm hopeful somebody or myself will respond. I usually check GitHub issues twice or thrice a week. Okay, going back here. So how do we do that? So how do we integrate Pycaret, which is just a machine learning library in Python? How do we integrate that with tools like Power BI, Tableau, Nine, SQL? How do we do that? So theoretically, many BI tools, including Power BI, provides the option to execute R and Python scripts. So it's very common these days. Theoretically, any integration that happens between machine learning libraries in Python or R between and the BI tools is through a Python environment. And so the same idea we have for Pycaret. The only thing different is in Pycaret there are exclusive magic functions built that would support the execution of machine learning in Power BI, right? And when we go to demo, I will show you what it actually means. So there are exclusive functions that are built for intended use outside of Jupyter Notebook. So they are not the normal functions that you would use if you are building your model in Jupyter Notebook, but they are exclusively for Power BI, Alteryx, Lime, and tools like those. Ideally, normally when we talk about executing Python script in any of the BI tool, theoretically there are two ways. One way, which I think which is pretty much common in Tableau, is you take your Python script and wrap it around a function in Tableau, and when you execute that function on front end, it would run that code and give you the results back. So, for example, if you want to run a predict model function, that you can wrap that around in a Tableau function and generate it on front end. Power BI doesn't support that. So Power BI uses DEX, data analysis expression language. That's the language you write in Power BI. You cannot wrap around a Python function within DEX. But what Power BI and most of the other tools support is you can integrate any Python library. In today's tutorial, we'll use Python. You can integrate it in your pipeline. So what is pipeline? Pipeline is a place where you prepare your data. So from practical standpoint, if you're working on huge projects, you would have heard about tools like Alteryx or Informatica. Those tools extract the data, transform the data, and load the data. Those are the pipelines, right? Ideal place to execute these kind of functions is in the pipeline. And what it actually means, if you're executing something in the pipeline, it actually means that obviously it would support batch predictions only or batch processing only. If you have a use case where you want to build a model and then use that model on front end as a web service or a web API, then obviously there are other ways to do it. You don't want to do it in Alteryx 9, Power BI, and stuff like that. Mostly I've seen the utility of integration in these BI tools for citizen data scientists who just want to do quick and dirty analysis, prototyping. In a very high degree production grade environment, it is unlikely that uh, you want to do machine learning on billions of rows in the pipeline or in the BI tool. So you must know that it's more for quick and dirty analysis, prototyping, and that kind of thing. But when you are dealing with billions of rows, you don't want to do it in the ETL pipeline because you usually have your own machine learning pipeline. Anyways, moving forward. Um, Okay, so today's tutorial is hands-on. So in next 5 minutes, I'll be opening Jupyter Notebook and Power BI, and would just do hands-on. And I assume people would follow that. But if you want to invest more time into this area and you want to read more, this presentation is there on GitHub, and you would see there are dozens of links here. So today we are going to cover machine learning. The first link, the anomaly detection, clustering, and one more supervised case. But then other than that, uh, there is a Medium post written by a colleague on machine learning in Tableau with Pycaret, and then there's another post of machine learning in SQL with Pycaret, which I highly recommend you to check it out if you are using SQL, because in this post we have shown how instead of bringing your data to the model, you can actually ship Pycaret's code into SQL and generate a model in SQL environment. Obviously, you need a Python environment, Python backend. So every time I say you need to execute this in X environment, Y environment, all it means at the end of the day, whatever tool or software it is running a Python backend, right? That's all it means. So nobody is replicating Python within itself. So even if you are running something in SQL, you would point it out to a Python environment, which is essentially an Anaconda environment that we have just created. Okay. All right. So our first demo for the day is ABC Insurance Company. This is the data set from Kaggle. And if you go on my GitHub link, you would see the source code, source part of the data set. So the idea here, and let me see if I can zoom. The idea here is that insurance company wants to improve its cash flow prediction. So what happened is whenever a patient is admitted in hospital, insurance company needs to figure out what amount of cash outflow would incur in next 7 days, let's say, so that they can manage their investment portfolio and have the liquidity available when it comes to paying the hospital or patient, right? In this case, let's assume there's an insurance company who has basic patient data, which is age, gender, BMI, children, region, and his or her smoking status. So nothing confidential, but some basic data based on which insurance company wants to predict whether wants to predict what would be the hospitalization charges, right? So that's the use case, and building on this, and here's a sample workflow. So we have a training data set. Insurance company has this training data set, which had all the transactions for last 6 months or 1 year, or this depends based on the policy of company, right? So all the training data set we would train the model and build pipeline in an ID or notebook environment. Today we'll use Jupyter Notebook, but you're free to use Google Colab or Azure Databricks or anything you want. And then we'll save the pipeline for deployment. And that pipeline is basically all the transformations that we'll do, and the last element of the pipeline would be the model itself that you can call on .predict. Now, if you these three steps are common to whether you want to do batch prediction or real-time prediction. But today, what we're going to do is batch predictions. That means we are assuming that ABC Insurance Company has an architect where the new data set is sitting in a data warehouse somewhere on Azure SQL Pass or Oracle or any cloud instance, or even on premises. Your Power BI, which is a client tool, is connecting to that database. And when you are connecting to that database, you are doing some transformations in Power Query, which is essentially a ETL tool that supports Power BI. So in Tableau, the idea, the Power Query to Power BI is similar to Tableau Prep to Tableau. And Tableau users would be aware about Tableau Prep. So you have a SQL database where your client tool Power BI is connecting to, and it is getting refreshed every night with the new data points. And Power BI is basically what happened is when you set the refresh in Power BI, it basically runs the whole Power Query script. And in Power Query scripts, that's the place where we'll inject the predict model command. So that every night when data is refreshed in SQL, Power Query would execute the function from Pycaret, and Pycaret and basically Power BI would execute that, and Power BI would use the same Conda environment that we have just created, right? But for in order to do that, we'll have to point Power BI to a Conda environment. So without wasting any further time, let's see how we can do that. So I'll open my Power BI. Okay. So here, under File, Option and Settings, Option, Python scripting. So File, Options, and Python scripting, and that's where you want to point it out to. So normally in Anaconda, and let me zoom it a little bit. Oops, I cannot zoom it, but normally on Windows 10 machine, and I don't know about Mac, but on Windows 10 machine, when you are creating a Conda environment, normally your environment is stored in this folder, envs. So if I go and go to this path, you would see I have two environments. Pycaret dev is basically an environment that I use for developing Pycaret, and this is what I've created for this tutorial, Power BI. You need to point your Power BI to this location simply by clicking browse button and looking for that, right? Very simple. So no rocket science. I'm seeing Moez S. You would probably see your computer name here, but normally you would find it under Anaconda 3 folder, envs subfolder. Okay, once you have done that, so what we have done so far, let's review. So we have, if you didn't had Anaconda distribution or Python, you had installed it with Python 3.6 or greater, then you have created a environment and installed Python. So these three things we have done, and the last thing was we have linked Power BI with that environment. Okay, going back to our use case, um, going back to our use case, okay, so what we need to do is first train the model, right? So I'll open my Jupyter notebook environment here, and let me zoom in a little bit. Okay, so I am using 1.0.0. I'm getting the data set. This data set is uploaded on our GitHub repository. So if you're using Pycaret, you don't need to worry about downloading the file or anything. You can just do get data. So you'll get this data set. Just like any other experiment in Pycaret, you want to set this up. So I'm calling my regression module in, setting up, passing the data set and the target column name, which is charges. Okay, if I don't care about data types at this point, I'll just say, okay, everything is good. And I get this, my information grid that I have 1300 rows. After transformation, I have 14 rows because obviously region is a region and sex is a categorical variable. So after converting them to one hot encoding, we have more columns now. And all the other information if you care about. I'll quickly run compare models. What it would do, again, if you have not seen this before, is it would take all the model in model library of Pycaret, which is essentially nothing but the combination of models in scikit-learn, XGBoost, GetBoost, Microsoft Flight GPM framework, and obviously the idea is to just keep adding, because the way we have created Pycaret is to have full architectural flexibility. That means we can expand horizontally. So obviously with time, we're going to add more and more external libraries. That's the idea. Anyways, while this is running and we have all the metrics. So how to choose your best model is definitely a lengthy discussion, right? But normally these are 6 common metrics that you would use, but also metric is not the only thing based on which you should choose your model. But for simplicity, let's assume today we are going with the model which is coming on number 1, which actually doesn't mean that's the best model, because there are more to it, and we are not going to talk about that today. But for simplicity, we'll just pick the top model. Top model, pretty usual. It's the XGBoost model with 83% R square and 2700 ME. I'm going to create my XGBoost model. Just see heteroscedasticity, looks okay. Okay, little bit of problem here, but it will work for today. Feature importance, very obvious. If you are smoking, your hospital bill is very high. Okay, and last thing before finalizing, remember when you do this setup, you are splitting this original data set into train and test. Everything that we do in Pycaret is on training data set. So all the results that you see here, or here, they are basically cross-validation 10-fold results. The test set is still sitting on site, 402 rows. We haven't touched them. And this is to basically give you one final chance to see if there is any overfitting or underfitting, because we haven't used this test set yet. But luckily, we have the label, so we can calculate the metrics. So we haven't used it in training, but we can still calculate R square MAE because there is a label attached to this test set, right? Okay, so this predict model, when you don't pass any data set into this, it would assume, okay, you are telling me to predict on a holdout set. That's why you see this result. That's because it's predicting on a holdout set. And if you see holdout variable, this is nothing but actually a data frame with your predictions at the end here, label column. Okay. So in this case, holdout set 88%, my XGBoost on cross validation 83%, pretty okay. I mean, it's not 100% reliable because the number of rows are only 400, but this is a good check that you should do. And if your cross validated result is 93% and your holdout result is 83%, you better check before actually deploying it. Anyways, at this point, we'll just go ahead, we'll assume everything is good, we'll deploy it. Before deploying, we need to finalize the model because remember, our XGBoost is trained on 70% of data set. We want to finalize it, which means fitting it on the 100% data set. So let me run it. So now we have final XGBoost, and let me save the final XGBoost model and name it Power BI deployment. And when I run this code, I get this message. And what it actually means is if I go into my C drive, users, and Pycaret, let me zoom in. You see this file here, Pycaret Power BI deployment.pkl. That's the file we have just saved, 79 KB. Pretty simple. And if I load back, this is not just the model, but this is the entire transformation pipeline. Because one thing that you have to think, and that people, if you are new to data science, you're not normally trained this way. But one thing that you have to think, even if this data set doesn't have any missing value, you still need few things like missing value imputers in the background, because tomorrow when the new data set comes in and it has missing value, and if you don't have imputer or transformers trained already, how would you impute the values, right? So that's why there are a few things that Pycaret would automatically do, and one of that it would always create an imputer, so that your system, when you run predict model, doesn't fail in production. Okay, so we are finished with the model training part or creating a pipeline part, which you can do it in Jupyter Notebook, Google Colab, anywhere, right? At the end of the day, the output you need from this process is a pickle file, which is saved in the folder that we have just seen. Okay, now let me open a Power BI file, and let's assume that that we are building a dashboard that would connect with the data set, with the database that would have the new data, and it would get refreshed every day, right? And our objective is to, when the new data is coming in, we want to attach a new column of predicted charges, so that somebody can, so people in business don't worry about anything. All they see is a front end tool, because we would basically inject predict model function in Power Query. So a developer would do that, a citizen data scientist would do that, but business wouldn't care. They would have a front end application, right? So, and in order to do that, I have created a proxy data set, insurance underscore unseen. This is also on GitHub. And this is basically kind of mimicking the real life scenario where we have new data set. I'm using CSV. You would obviously, in production environment, it is unlikely that you will have the data set in CSV, so it would basically connect with SQL, but the same idea. It doesn't matter where the data set is coming from. Okay, and let's see, just to make it interesting, what I have done is I have created null values in the data set at many places. And what I've also done is I've created these three new columns, new call 1, new call 2, new call 3. They have nothing to do with our machine learning model, but that's the reality. When you are dealing with, when you have dashboards in production, you don't exactly get the same data frame. You have to live with what you have. As long as you have the same column names, you have the column names that the model will train on. These new columns should not be a problem. So we have basically taken care of that in Pycaret. Normally it would fail, but we have Pycaret has the ability to ignore those columns. Anyways, first thing you have to do is click transform data. that would take you to Power Query. Okay, once you are in Power Query, so this is your Power Query environment. And remember, when we talk about theoretically implementing it, what I meant to say is we'll just execute a Python script. So this Power BI is pointing out to an environment named Power BI. And in that environment, we have Pycaret installed. If you don't have Pycaret installed, it won't work, obviously. Okay, first step, add column, sorry, transform, run Python script. And when you click here, all you see is this window, just one white box. And theoretically, you need to understand you can execute any Python script here. Obviously, it's not easy to do because this is not an ID environment, so there is no uh, auto completion. There's nothing like that. It's just like a notepad, right? That's why Pycaret, you would find it useful because you don't actually care about uh, writing 10 line of code because it's just one line, and it's highly unlikely you will make mistake because it's not even a code. It's like an English line, right? Predict model. Anyways, one thing to remember that whenever you are executing Python script in Power Query, you get the input in a data frame called dataset. So this table that we see here, this table is automatically converted into a data frame, and this is stored into a variable named dataset. And this concept is similar for all the other tools. If you go and try to execute this in Alteryx, you will see a note somewhere that this table is stored in a variable ABC. Same thing for 9, and same thing for other tools commonly. So in Power BI, this table is stored in variable called dataset. That's good to know. And the first thing you will do, Pycaret.regression import all. This is something you're doing in your Jupyter notebook as well. And then we have to load the model. To load the model, you'll just load the model. Load underscore model is the function. I'll go to this location and copy this path. And obviously you need to change the direction of strokes, and then this has to be string. And what was the name of our file? You don't need to put .pkl, you just need to put the name. So what I'm doing is load model and just giving it the path. That's where the pickle file is saved, the file that we generated from Jupyter Notebook. And then finally, I'm saying dataset, predict underscore model, use model, and the data is dataset. Why dataset? Because the input data is stored in variable dataset. And I would just run this. And when you run this, if it asks you about data privacy, you can just ignore it. I'm getting this message because I have just downloaded the file from Git. That's why. Okay, it may take a few minutes. All right, so this is the kind of output that you would get. You have to click, if you see this table, this is a hyperlink, and I'm sorry, I cannot zoom in the Power Query environment, but this table is a hyperlink. So you have to click on table. It will load for another few seconds. You can see this. All right, here we go. And you see this. We have this same data set that we loaded. We still have missing values in several places. We still have these extra columns, new call 1, new call 2. We didn't have to delete them. We didn't have to erase them. But we still have the label column, which is essentially a prediction. So imagine what happened is when you pass that predict model function, it's not just the model.predict, it's actually the entire pipeline. So it imputed the missing values. It converted female male into one hard encoding. It does whatever you asked it to do in the setup function, which could essentially be creating new features on the fly. So if we do that, what predict underscore model here would do is it would execute the entire pipeline in sequence. You would get your results, but you don't want to change this entire table, right? Because all these fields are used by your front end application, and your business or domain experts not necessarily care about 1010. They need a human readable output, right? So in that sense, it's really valuable. Now I can just close and apply, and I would have my data set in Power BI to work with. So after this point, this becomes like a normal data set in Power BI. You can do whatever you want with it. Now, one common question, if you are a Power BI user, you would ask, okay, how would my dashboard would get refreshed in production, right? If this is an app used in production, how would that happen? For that to work, you should check out my Medium post where I've explained that you'll have to install Enterprise Gateway, which is nothing but a very small software on your computer where the Python environment you have. And then obviously your computer has to remain open during the time your scheduled refreshes would run. Okay, we have this data set in Power BI just to show you. We have label column here, right? So incredibly powerful. Um, so this is the idea behind supervised learning. We have seen regression. It could be classification. It could be multi-classification. It could be anything. But that's the idea. Uh, how would you translate this into Alteryx or Nine or Tableau? Not Tableau, but Nine, Alteryx, Informatics. Pretty similar. ClickSense, pretty similar. There is a way to execute a Python script. All you have to do is just find the option. Like in Power BI, you can see that option here. Sorry, under options. For other tools, you'll just have to find the option to point out to the Python script and then just execute it. So pretty much seamless. Okay, now let's quickly move to our second use case, which is, let's move to our second use case, which is anomaly detection use case. So, and what it is. So I have used this data set from state of Delaware, US, where what they have done is their employees, state employees, have credit cards to do company expenditure, right? And it's pretty common. And because it's a public sector entity, they're bound to release the data set online. So it's an open data set. It's a very big data set. So I have filtered that data set for Department of Education only. So what I have here is a data set, and let me see if I can zoom in. What I have here is a data set which has each row is a transaction, and there are details of transaction. So which department, which division, what was the expense description, what was the transaction date, what was the merchant name, what was the merchant amount, stuff like that, right? A classical traditional transactional data set. And our goal is to basically detect anomalies or outliers in an unsupervised way, because there is no label, there is no column indicating whether it's a outlier or anomaly or not. And why do we want to do it? Because normally all this process, when employee has incurred company expenditure on company issued credit card, employee would submit the details online. All this process is mostly automated. So there's no human sitting in between actually going invoice by invoice. At least this is becoming very normal now. So people can use this outlier detection to kind of flag the department who is doing this review or audit, to kind of give a starting point to review the transactions that are flagged as an outlier by automatic anomaly detection model. And this is an unsupervised problem because there is no target column, so we have to rely on algorithms such as isolation forest or one class support vector machine to identify the transactions. Now, you can you can implement this thing in Jupyter Notebook, just like we have done classification or regression. Similarly, you can do anomaly, and there are a bunch of tutorials and videos out there you can see. But today, we would use a magic function that we have talked about in Power BI to execute anomaly detection on the fly. So you don't have to open Jupyter Notebook, load the data set, set up the environment, create the model, finalize the model. No, what magic function would do is it would basically execute the entire chain by one word, because In unsupervised learning, there is no train test split, right? So normally when you are doing clustering, in the most simplest way, think about this, you're when you're doing clustering, you could be doing clustering because you want to understand that data set. It's not every time that you want to have a trained clustering model and you want to use it to predict the labels on unseen data set. Now, there could be use cases like this, but many times you would want to assign the labels on the same data set as well, right? And it's very common in unsupervised learning. Obviously, in this scenario, if you want to implement a full-fledged anomaly detection system in production, you would obviously want to have a model pre-trained and then serve it as a pickle file in Power BI or any other environment, just like we did for regression. But today we will look at from the perspective where you quickly want to analyze a data set, detect the outliers, flag it, and build a dashboard out of it. So that's what we'll do. And okay, so let's get going. I would open my new Power BI file. Okay, so this data set is also uploaded on, you can obviously get it from the original source, but that would have all the departments, and I've filtered it to Department of Education only. So you can get it from here. You don't need to download the data set in Power BI. You can actually get the data set directly from web. So that's what I'm going to do. Get data, web. I'll just paste in the URL. Oops, I think I have got the wrong link. Yeah, I have wrong. Sorry. This is the link. If you have to execute, this is the link. Web. Okay, this is the data set. So again, I will not load it. I'll just transform it so that I can get into Power Query directly. And okay, before we see, let's talk about a few problems. See this column, department name. This only has one value. One option is you can delete the column from here. But that means that your application, which is using this column somewhere, would also be lost, right? You don't want to do that. Also, this data set has a date column, which we want to ignore for now, because we are not doing time series anomaly. And this data set also has a merchant column, which is highly cardinal. So there are thousands and thousands of them. So if you attempt to do it without ignoring it or without compressing it using some technique, you would end up running out of memory because it would be a giant sparse matrix. For today, I'm going to ignore the merchant column, transaction date, and department name. One way is I could just select the columns and delete them before running my script. But again, if you are using those columns in front-end application, you don't want to get rid of it. So similar to what we have seen for regression, starting point is run Python scripts. So very simple. And this time we are going to do from Pycaret.anomaly import all, and the command is get underscore outliers data is equal to dataset. And then
Okay, just one question. How do you know that it is pointing to the same Power BI environment, like when you are running the script?
here, I can't zoom in, but if you would see, it says here, the script will run with the
Okay.
following.
Okay, you initially set that environment, right? Yeah, yeah,
Yeah,
continue. I got it. Yeah, yeah.
yeah, only set that once.
Sorry.
Okay, so we have to ignore these three columns, right? So ignore underscore features. We can obviously delete them, but I'm telling again and again, our purpose is not to delete or mess up with the columns that you are using for your BI application. Because remember, you are doing this because you already have an existing BI application and you now just want to introduce some basic machine learning use case in that. So you don't want to mess up with the other column, because the moment you do that, I don't think so you're gonna get sign off to implement that. Or people would, you can get a buy-in for that. Anyways, so in ignore features, we would pass these columns as a list: merchant, France date, and department name, right? And obviously, I am not passing any model here. There are 10 models that you can use, 10 algorithms, and you can, while this, let me run this first. So I'll tell you why I'm not passing any model. So what I'm doing is just get outliers, data is equal to data set. Why data set? Because the input data frame is mapped into a variable named data set. And then just ignore these three features. I'm not passing anything else, not the name of algorithm, not the contamination parameter. Let's just run it simply. Okay. While this is executing, let me show you. There are many models. So if you go to Pycaret's website and then go to anomaly detection in the modules, you would come to this page, and under this page, if you see the Docker string of create model, you would see all these estimators are available. So from angle-based outlier detection to subspace outlier detection. By default, if you don't pass anything, it would use isolation forest, which is like pretty famous and common, but you can change it by just passing model parameter. Okay, so this is still executing. We'll give it a minute or so.
Probably, I think we need to have a very good amount of RAM, right, for executing all these things. We are considering Power BI, I guess, right? At least
Yeah.
16 GB.
So with Power BI, my experience is first thing is don't use 32-bit version. Okay, we are completed. Let me, so same thing, we'll have to click table and it would take some more time. With Power BI, my first thing is if your Power BI is slow, the first thing you should check is whether you're using a 64-bit or not. Normally, people would use 32-bit to make it compatible with their Microsoft Office. So if you're having issues, the first thing you should do is uninstall your Office, uninstall your Power BI, get a 64-bit version. There is no possible way that you'll be able to build something production ready in a 32-bit environment. The second thing is Power BI consumes your, because Power BI behind the scene runs a local SSAS tabular instance. So it consumes a lot of memory. So if you are working on huge data sets and actively working on your laptop, then either you need to increase your memory size or either work on sample. So what I do is at work, what we do is whenever we are working on development, we restrict the number of rows in Power Query so that developer who are working on their local computer would only have 5,000 rows to work with. But when we publish it to service, that's where the whole data set would come in. So I think that's one way to to make it work with Power BI. In terms of speed of execution of Pycaret and Power BI, I think This load time has more to do with the way Power BI handles data type than anything else. So if this is taking a long time, and I know there are many people who have logged the ticket to Microsoft as well for errors relating to data type, but there's nothing we can control there. Um, Anyways, while this is all this is doing is basically iterating. Power BI is iterating by columns and trying to detect the data type again, which I not necessarily understand why it is doing it again, but it would do. Okay, so once this is complete, and also I like if you think if you are planning to use this in production as a batch processing, the processing time of 5 or 10 or 12 minutes wouldn't matter much because it's going to happen overnight anyways. So not that you'll be able to use it on production system with billions of data points, but again, it's small to medium size, you can easily rank. Anyways, when this completes, this basically returns you the data frame which has okay, there we go. This has written you a data frame with label column and anomaly score, right? And one is an outlier and zero is an inlier. At this point, when I close and apply this, I would get this data set in Power BI, and then I can do whatever I want with this. In this case, I'm not gonna apply it because I don't want to build dashboard in front of you, but I already have a dashboard which I have used. So anomaly detection. Let me open this file. And again, this PBIX file is on GitHub. So if you want to replicate this, what we are doing now, I encourage you to go to GitHub slash Pycaret and look for Pycaret dash deployment anomaly. You would find the dataset. You would also find the Power BI file, and you would find a link to a complete Medium post, which is basically a 10-minute read of all the things that we have seen today already. So feel free to read if you want. Okay, so here's the dashboard that I have built based on the anomaly detection scores and the labels. Right, and let me just, in fact, you know what a good idea would be to just open it on service. Not only that I have built it, but I've also published it on service. So give me a second there. I'm opening in here. And you can see that I have anomaly detection in Power BI, which is this one. So here's the dashboard. And obviously, one disclosure is my intention when I was building this is not to detect the outliers in the state employees of Department of Education. This is just for demonstration purpose. You obviously you can build whatever you want, but the idea is that we have used that label column to build the dashboard. Um, right, and so in this case, so for example, this table here, here's how you would present it normally. You'd have all the transactions and then flagging what is outlier and what is not. In this case, it makes sense to me that all the transactions are pretty small, but this one, and not just the amount, but also this is the PayPal charges. Isolation Forest has flagged it as outlier. Uh, Kind of makes sense to me. Same here. So Although it may look like all the higher transactions are flagged as outlier, but that's not the case, because it's not just the amount column that isolation forest knows, but also the other dimensions too, right? Anyways, so this is outlier for clustering. What I'm gonna do is not execute the code, but just open the file. The idea is pretty similar, and you will see while the file is opening, I would show you same thing, GitHub repositories, and you would see Power BI dash clustering. You would find the dataset, and you would find the PBIX file. And the reason I try to make things simpler and simpler, I try to cut off all the import steps and all those steps in the middle so that I can encourage more people to be hands-on. So the only way to learn it is by doing it yourself, because otherwise it means nothing, right? Anyways, so I encourage you guys to do hands-on, and if you have questions, you get stuck, do post your issues on GitHub. There are people who would help you. I would try to do as much as I can to respond to you on LinkedIn, but GitHub is the best way to report your issues. Anyways, so this is the clustering, same thing. So I have taken the data set from WHO, and I'll show you the data set, how it looks like. So this data set has all the countries, around 200 countries, and the percentage of health expenditure as divided by their national GDP. So basically, what this means is Afghanistan has spent 0.09, which is a very good percent, 9% of its GDP on health. And by country, so it has a bit of time series element at a country level. So you would find 200 countries here. So I have used this data set to kind of create a natural grouping of countries that have very high spending or very low spending. And how we have done that, so we'll see the insights afterwards, but let's go to Power Query environment to show you. This is exactly same. This is exactly how you would do anomaly detection. So there's actually nothing to tell. So let me show you the script. From Pycaret.clustering import all. In outlier, we have written get outliers. Here you would say get clusters. Ignore features country. And number of clusters, if you want, you can pass. If you don't pass, by default, it will be 4. So exactly same thing. So you don't even have to remember anything. It's exactly same thing, right? And once you close and
Moez,
apply,
just one question. Regarding the, as you said, right, you have ignored countries, right, and probably countries may be many, and internally it will be doing one hot encoding. So instead of one hot encoding, is there any efficient, encoding techniques as such in
right,
case?
right. So yeah, in case of clustering, you obviously you want to ignore country, right? Because you don't want country to become part of a clustering algorithm, because there's only one country, one row in the data set, right? So for clustering, we are ignoring country because we don't want country name to get clustered, right? But for supervised problems, um, and especially there are exclusive challenges on Kaggle that deal with encoding of high cardinality variables. So in pre-processing, you would see we have this technique called cardinal encoding. So if you have a factor which has hundreds and 500 level, let's see, and you don't want to do one hot encode because it would create a very sparse matrix. You don't want to do it for any mathematical reason, or you don't want to do it for performance, or you don't have enough memory in your laptop. Either way, you can use cardinal encoding, which basically under the hood uses two different methods. One of it is unsupervised clustering, and one of it is to basically replacing the variable with the count of the variable. That's one of the method to deal with it. So you can see in here we have a native country name, right? And there are so many countries. And if you use this technique, it would get converted into a number, which is essentially nothing but a count. So that's one way to deal with high cardinality variables in Pycaret. The other way is obviously to merge the levels which are not so much popular. So if there is a country that is only appearing 10 times in the data set, you can use this group features, No, not group feature, sorry. You can use ignore low variance, and there's one more. Where is it? Okay, I can't find it for now. But there are ways. There are ways to do that. Does that answer that question?
Yes,
Okay.
Moez. Thank you. Yeah.
So once we have executed that clustering thing, you can see. So I have changed this a little bit. I've normalized it basically so that I have all my years in rows instead of columns. So just a normal normalization. But what we care about here is this is what I wanted, cluster label. This is exactly what we get out of Pycaret, right? And now I can use this in whichever way I want. In this case, to my surprise, I've never heard about Marshall Islands before, but apparently Marshall Islands is spending more on health than US. Uh, and also you would see there are 5 clusters, so we have very good clustering, and you can see cluster one, which is basically mostly, if I interact with this, obviously North America, United States. So cluster one is spending 14% on an average of its GDP, then 9, then 7, then 5, and 3. So it's kind of pretty useful in that sense, right? And with the amount of time that we have spent to get this insight out, it's brilliant, right? Obviously, when you are doing clustering, specifically clustering, then you need a lot of iteration because your clusters have to make sense, right? There is no target, there is no number. There are metrics that you can put on to measure the performance, but it's actually not like supervised learning, right? So for clustering, you need more business sense, and then you need more, I would say, acceptance to your business hypothesis than actually any mathematical method. So that's the whole idea. And you can see, let's see what we have on details page. Right, so we have all the countries here by clusters, and you can see a profile of any country. For example, let's um, let's pick Saudi Arabia, 4.2%. Right, so I think that's it for clustering. Let me see if I have anything else here.
Probably I've learned a lot from this session, you know.
Yeah,
I'll also give a try with respect to Power BI. And it's amazing, you know, like how we are able to integrate it so easily and be able to run very quickly, right?
yeah.
Uh,
So one thing that we haven't specifically covered, but you can obviously see it yourself. If you would check out our Medium stories, and you would read this one, machine learning in Power BI using Pycaret. This story has all the use cases, and one thing that we haven't covered here today is if you can do get underscore outliers to get the anomaly, get underscore clusters to get the clusters, then it is very obvious that you can also do get underscore topics to get the topic model. And if you have done NLP before, you would know it's not straightforward, especially for NLP. You have to go through entire text pre-processing pipeline, bigram to trigram to tokenization. So when you write get underscore topics, it actually does all those 14, 15 pre-processing steps, and then train a latent LDA model. And then even if you are doing in Python and you successfully pre-process the text and train the LDA model to get the proportion out of model, it's not as simple as sklearn. It's a pain, right? In this case, when you do get topics, all you get is a data frame out, and you can see this is Power Query. You have your text here, and you have nice and clean proportions into columns. So very easy. So I encourage you to, and obviously then you can just visualize it whichever way you want. So I encourage you guys to follow that, and I would say it's so easy. Just do it. If you are hesitant to use Git, just use it. If you're hesitant to actually practically do it, just do it. There's no other way to learn. There's no other way to learn. All
Okay.
right. So handing over to you, Krish.
So thank you, Moez, again. Wonderful session. I have learned a lot. So probably viewers will love it, when they are implementing completely from scratch. Thank you for this amazing session, and thank you once again for giving your time. I know you're a busy person as such, and you really want to contribute to the data science community, by providing all this particular information. It was amazing to have you on, and probably in the future, again, we'll have some of the other thing as we go ahead. Again, because we are planning for Tableau also, if possible. Based
Yeah.
on your time, definitely we'll try to conduct a session again. So thank you, Moez, once again. Anything you want to say before wrapping up the session?
No, I think thank you, Krish. You are doing a good job. I think more and more people are hesitant um, to actually practically do it. It's okay to listen to things and watch things, but that would not make you answer. So I think your approach of teaching, I like that. It's a simplistic approach. You can see I'm going in the same direction. I try to simplify processes as much as I can, and Pycaret 1.1 is coming, and 1.1. If people have like 1.0, I think this is really something to look forward to. It would blow mind of people. It's gonna have a full UI driven stuff. So I'm really
So what are the
excited.
new things that are coming in 1.1?
So the biggest thing is Pycaret is going to become a command line utility, which means that at the moment it's very ideal for Jupyter Notebook environment or Colab environment. But when we release that, many people who are very typical traditional data scientists, they love to write things on command line. Even though it may sound to you and me, it may look like, why would you not use Jupyter Notebook? People are comfortable with command line. So next release, Pycaret would be 100% compatible with command line, which actually means that you can use it and run it in any server. The other big change would be Pycaret. At the moment, you still need human being, right? You would run compare models, but you still need human being to eyeball it, which model is better. The next version is gonna be would support complete automation. That means even if you're not sitting in front of computer, the way we are designing it, computer would basically Pycaret would make decision automatically which model is better and move on. So kind of a modular AutoML system. And it's not AutoML, it's modular AutoML, which means using Pycaret, you would be able to build your own customized AutoML. So I think,
Perfect. Amazing. Amazing. I think I can now understand like what will happen as soon as 1.1 will come. But definitely I'll give a hand up again over there, and probably I'll call you again if you want to really talk about 1.1 in the later stages as soon as it is released through my channel. So thank you, Moez, again for giving your time. It was awesome to have you again, and probably in the future we'll have you again, as I said. So
thank you,
thank you,
Krish.
guys. Yep. So thank you, guys. So this was all about this particular video. I hope you like it. And probably I'll call again Moez, and it is based on your request. I'm actually calling him, and he's able to give his time. So I'll see you all in the next video. Have a great day. Thank you, one and all. Bye bye.
Take care. Bye.